Guys, today's topic is translation. So we are now entering to advanced things. Okay, so today onwards we are starting translation. My first question is, what is translation? What is translation? First question. And why do we need translation? These are my two primary questions. Anyone aware of it?
Some modify the source or destination IP port of packet while it's passing through the firewall.
Modifying source or destination IP for?
IP address for packet while transferring through the firewall.
Okay. So translation is all about converting private IP to public IP, okay, or public to private communication. This is where translation comes into a picture. But there is a question mark. Why do we need a translation? Most of the time, you guys will tell to communicate over the internet. That is true, but that's not a fact. That's not only a reason. There are two versions of IP. There are two versions of IP, IPv4 and IPv6. Understood? IPv4 means IPv4 is 2 to the power of IPv4 means 2 to the power of 32. Correct? And when I say IPv6, it's 2 to the power of 128. Correct? Have you guys gone through IPv6? Do you know IPv6? In IPv6, did you learn translation chapter? In IPv6, did you get any translation? No, you didn't get it. Reason? In IPv6, we don't have any translation concept. IPv4, IPv6, major difference. In IPv4, only we have a translation concept. In IPv6, there is no concept of translation. Reason? It's an old version. It has limited IP. IPv6 has enough IP. IPv6 does not require any translation. Reason? For upcoming 50 to 60 years, if I keep assigning single public IP to each and every host, I can fulfill the requirement. That much public IP I have with IPv6. But with IPv4, multiple conditions are there. When I talk about IPv4, we have class A. In this also we have a range of private and public IP. Again, We have class B, we have class C, we do have class E, D, and we have class E, which is used for multicast and broadcasting purpose. So in our daily communication, we don't use D and E, we use A to C. In A to C also, what I told, we have a range of private and public IPs. Now, the problem is, first of all, this range itself is very less. In that also, we have cutoff of private and public IPs. So number of public IPs that we have in IPv4 is very limited, respective to growing number of internet users. Now, if you talk about growing number of internet users, just imagine till Geo came in a picture, 2016, if I talk about this was the time when Geo came. Think once Geo came in India, after that, how many internet users came up? Rapidly grown, right? I mean, जियो आने से पहले हम लोग इंटरनेट कैसे यूज करते थे? ज्यादातर कोई स्मार्ट मोबाइल नहीं यूज करता था, और जो भी यूज करता था 1 GB डेटा को हम लोग पूरे महीने ले जाते थे. We used to use 1 GB data for entire month. In that also we used to turn off data, we used to turn on data in smartphones. That's how I have that experience of using it. Okay. Correct. Coupon codes, scratch code. So we have range of private IP and a public IP. So I was talking about growing number of internet users. So you guys can imagine after 2016 how rapidly internet users has grown in India. Right now in villages also each person's you'll see using smartphone, creating content, uploading. I mean so many things are going on, right? So that happened only because of Geo. I believe that was the part when it initiated things, right? So that was the turning point of internet users in India. See, if in one home, if I talk about inside one home, we have so many devices to connect, right? We have smart TV, we have smart watch, we have Alexa, we have like each person two devices at least will have one phone and laptop for one guy. And if we have two, three guys, then obviously into three, if you say that much gadgets will have in our home. So each device will be considered as a one host. It means each gadget is considered as one public IP user. Okay, like that you guys can say. So this is how you can understand the number of users getting increased in our network. So at one home, one, two, three, four, five, again, at least 10 devices will be there at home getting connected with the internet, right? Do you think I'll be assigning each user one public IP? No, not possible, right? So if I purchase 10 public IPs and if I get into, let's say, with the 10 users into 10 public IPs, okay, that will be into, if I put 2000 only per user, that goes somewhere around 20,000. So do you think a normal family can afford this much? Not possible. Per month you can't afford it, which is not possible, right? So we came up with a temporary solution, and that temporary solution is nothing but it's a translation. So translation was the solution to overcome shortage of public IP in IPv4. So when you talk about shortage of IPv4, shortage of public IP, then you should mention IPv4 version, not IPv6. In IPv6, we don't have a shortage of any public IPs. We have enough number of public IPs that can be used for upcoming 50 to 60 years. That much we have. So the problem is with IPv4. In IPv4, we need a temporary solution that can resolve the internet access of the users. Right now, you guys are in a CCIE hub. So at least I might have 50 users minimum, because you guys can see, like in that room we have 5 guys, here we are 2 guys, staff members, everything. So we have around 30 guys at right now present. 20 devices also might be connected with the internet, right? That is very less, I'm telling. So approx to 50 to 80, devices might be connected in a network right now. For us, is it possible to take that much public IP? No, not possible. So what we do, we use a translation. So translation basically helps you to translate multiple private IPs with single public IP. Okay, this is where we use a translation. Guys, did you understand why do we need a translation? Main concept is clear. Why translation is required? See, again, I'm repeating it as a conclusion, I'm telling you. Most of the time when you guys are asked, why do we need a translation? Your So guys, what we have to understand here is to see, I was talking about conclusion of why do we need a translation. So conclusion is, don't start your answer with we translate private IP to a public IP or public IP to a private IP. Don't start the conversation with this. Tell clearly, first of all, in IPv4, we have shortage of public IPs, because in IPv4, total range of IPs we have 2 to the power of 32, in which also we have different classes, and till class C we have a range of private and public IPs. So limited public IPs we have, which is not enough for growing number of internet users. If we start assigning single public IP to each and every users, it won't fulfill the requirement. So we came up with a temporary solution called as a translation to fulfill the requirement. Because let's say in one organization, if I have 100 users, I might take 2 public IPs to fulfill the requirement. See, one public IP can give access to 500 users also, but that's not a requirement. Okay. Thing is, when see, I have to see bandwidth also, right? I mean, if one public IP is accessed by 50 guys, then bandwidth will be also utilized. So in general, multiple private IPs can be translated with your public IP. That's basically the answer. Okay. Also, you should include that we use it to communicate between private to public. Don't forget to mention this. What you were telling answer, you should keep your answer, but you should give it at last. First, make them realize that why do we need a translation? We need a translation because there is a shortage of IP, public IP in IPv4. And after that, we have to fulfill the requirement, so we do a translation in IPv4. Whereas in IPv6, we don't have a concept of translation. एक टाइम के बाद ट्रांसलेशन एक चीज होती थी IPv4 में, ऐसे बोलेंगे। क्यों बोलेंगे? क्योंकि अब उसकी जरूरत नहीं है। IPv6 में कोई ट्रांसलेशन की कोई कंसेप्ट ही नहीं है। So in IPv4 we have a concept. If someone is telling we use translation for security purpose, क्या security करते हैं? Encryption apply होता है, Authentication होता है, hashing होता है? No. So what type of security? Nothing. So this is nothing but it's basically a temporary solution to resolve your internet access issues. Okay. Am I clear with translation concept? Did you understand?
Yes, sir.
Okay. Now let's discuss about types of translation. So basically we have two types of translations. One is source translation and another is destination translation. There are two types of translations basically. See, I'm not talking only prospective to Palo Alto. In any firewall, concept-wise, two translations are only there. To complete source translation or a destination translation, we have multiple types. Now we have dynamic NAT, dynamic PAT, static NAT, and we have static PAT. These are the four major types of a translation used to resolve source translation or a destination translation. Is this clear? So we have a source translation, we have a destination translation. Most of the time, I'm not saying all the time, most of the time, like 95% of the time, we use dynamic NAT and PAT for source translation. Okay. And most of the time, 95% of the time, we use static NAT and static PAT for destination translation. See, if you ask me, can't I use a static NAT and PAT in a source? My answer is yes, you can. If you ask me, can't I use dynamic for destination? I can. But reasons are there why you can't use it. Still, I can say static NAT and PAT can be used in a source translation as well. It can be. But overall, if you see, we don't use. We use static NAT and PAT mostly in a destination condition. Okay. But if someone asks you, hey, can't I use the static NAT and PAT in a source? You say yes, you can use it, but not all the time. Conditions are there. So you can't deny saying that static can't be used for a source. It can be used. Now, they might ask, like, can't I use dynamic NAT and dynamic PAT for a destination? It can be. That's why I've written 95% of the time. I didn't write 100%. It can be, but 95% of the time, majority is statics are basically used on a destination side and static are used on the source side most of the time. Okay. So I'm not denying that it is not used. It is used, but depending. Okay. Now, guys, we'll see uh, we'll see source translation. In a source translation today, we'll see dynamic NAT first thing. So what is dynamic NAT? What is dynamic NAT? It's basically we create Pool of public IPs. Correct answer. Right. Other point. Equal number of private and public IPs required. That's why we call it 1-to-1 ट्रांसलेशन। देखो, अगर एक प्राइवेट आईपी है तो उसके लिए एक पब्लिक आईपी चाहिए, 10 प्राइवेट आईपी है तो 10 पब्लिक आईपी चाहिए, इसीलिए उसको क्या बोलते हैं, 1-to-1 ट्रांसलेशन। नाउ सी, इफ आई हैव 10.11.11.1 as a private IP, 100.1.150.1 as a public IP. Okay, so this is our 1-to-1 IP. Now see, let's say we have six private IPs and 5 public IPs. Let's say this is 2, 3, 4, 5, and 6. Okay, this is also 2, this is 3, this is 4, and this is 5. Understand how many public IPs I have taken here? 5. How many private IPs? 6. Okay. Now understand here. Here you have to understand two things, guys. One is dynamic, another is NAT. Two things. Dynamic, NAT. Two words you have to understand here. One is dynamic, another is NAT. Dynamic means will keep changing. It's not fixed. NAT means IP to IP translation. PAT means IP and POT address translation. Okay. NAT means IP to IP. So here you see only I have mentioned IP. See, this guy initiated a connection. This IP might be free. It will take first come first serve basis. जो available है, जो सबसे पहले है, उसी के साथ चलेगा. Dot 2 initiated, got translated to this IP. Dot 3 initiated, so respectively they got translated to 5 IPs. Now I don't have a IP in a pool, so this sixth guy will not be able to go. Reason: pool has exhausted. Pool is exhausted. So I can't go. I have to wait until anyone leaves the public IP. Now let's say this guy is initiating a connection. It will get translated to this IP. Now this guy initiated a traffic. It got translated to this available IP. Dot 5 initiated. Dot 2 initiated, and pool IPs are almost getting exhausted. Dot 3 initiated. It got translated to this IP. Now dot 4 does not have any free IP. Now, what did you understand with this? That IPs are changing. Translation IPs are changing. That's why we call it as a dynamic. NAT means for one IP, I need one public IP. That's why I call it as a 1-to-1 translation. In real time, do we use dynamic NAT? Till now, I haven't seen. It means 99.9% we don't use dynamic NAT. This concept is not used. 99% 99.9% I'm saying this concept is not used in a real time. But still I'm showing you practical of it. According to production network only I'm telling. Even at home also. Do you have 10 public IPs? Do you have 5 public IPs? No. You have one internet connection. That internet connection has one public IP. That is dynamic. You are not taking static at home. You are taking dynamic. So that keeps changing over the time of period. Right. Right now, here also at first floor, I'm not using static public IP. I'm using dynamic. So how to know what's your public IP? Say my public IP. Go to this website. It will detect your public IP. This is my IPv4 public IP. This is my IPv6 public IP, IPv4. And this is of Airtel in Noida based Uttar Pradesh. And this is my location. So I can see what's my public IP for today's internet access. And this is not constant. It will keep changing. It does not remain constant. That's why we call it as a dynamic public IP. Okay, so router is automatically getting this public IP and router does a translation. This is what it does in a backend. Okay, so this is our dynamic NAT. Whereas in a real time, we use in real time, we use dynamic PAT. So in a PAT, what happens? In a PAT, in PAT, IP and port both are translated. Both are translated. It's not only IP, it's also port number. But here, only IP to IP translation happens. Understood? There's no port number included here. So this is all about dynamic PAT. In real time, we use a dynamic PAT. In PAT, IP and port both are translated. Now you have to understand in a dynamic PAT, what happens? In a dynamic PAT, basically port gets translated. Now you all have to understand about the port number, from where the port concept came. Now there is something called sorry. It's INA. INA stands for Internet Assigned Number Authorities. Numbers Authority. Please take a note of it. INA. INA stands for Internet Assigned Numbers Authority. This is INA. So what does INA do? See, INA was an organization who came up with the concept of service name and transport protocol number registry. So at the transport layer, whichever port number you see, TCP based and UDP based port numbers, that concept was given by INO. So note here, I want you guys to note down this one. When I talk about a range of port numbers, range of ports, it's a 0 to 65,535. That's basically a range. It's basically a range of port numbers. Okay. Port numbers are assigned in a various ways based on three ranges we have. One is system range. System port range is 0 to 1023. Second is user port range. And the last one is dynamic IP or a dynamic and or private port numbers. So these are the three range of port numbers. Take a note of it. These are three range of port numbers. Now out of this 0 to 1023 which you see, not used in translation. Understand? So in 65,535 minus 1023. Okay. So if I say total we have 65,535. In this you have to subtract minus 1023. Right? Again minus around 500. Why you have to minus around 500? Reason, if you see the range of port numbers, if you see common port range numbers here, see these are standard port numbers, you can't change it. For example, 80 is for HTTP. Can you change this? No. We use 53 for DNS. We use 49 for TACACS, 69 for TFTP, 443 for HTTPS over SSL. Same way, we have multiple port numbers. So if you see from 1024, after 1024, we have 1025, 1026 and all. So many ports are there. And so many port numbers are not listed also here between 1024 to 65,535. यहाँ पे देखो देखो 0 से लेके 1023 तक तो ये तो ऑक्यूपाइड ही है 1023 port numbers. It won't participate in a translation. बाकी रहा 500 more जो कि ये जो है 1024 से लेके 65,535 इन रेंज के अंदर, इस रेंज के अंदर इतने 500 port numbers जो होंगे वो यूजेबल नहीं. तो 65,000 में से 1023 और 500 को डिडक्ट कर देते हैं, तो अप्रोक्स वी हैव 64K ports. We have around 64K ports. So one public IP can be used for how many port numbers? 64K port numbers. So if you have one public IP, with one public IP, how many port numbers can be used? 64K. That's the answer. With one public IP, okay, with one public IP, approx 64K ports can be used. That's the answer. Oh. Now there are two, three tricky questions over here. Okay, try understanding the tricky questions. Tricky questions can be with one public IP, how many ports can be used? They'll give you option of 65,535. They'll give you option of 64K, 64,000. I mean, they'll give you some other range of port numbers, right? In such cases, you have to choose the correct answer as a 64K. In interview, if they ask you to justify why 64K, then this is the reason you should tell. According to INA 10232, sorry, 021023 is not used in a translation, and between 10242, sorry, 10242 65,535, we have around 500 standard port numbers which is not used. So if you deduct these two from 65,535, then we have approx to 64K ports available. This is justification. Now they might ask you another tricky question. How many users can use one public IP? Then your answer should be one. See, question is one public IP can be used with how many users? That's a question. Answer is if user creates multiple connections, multiple sessions, then it depends on number of sessions per user. अब मान लो एक यूजर ने 50 सेशन क्रिएट कर दिया, तो अब मैं एवरेज लेके चलूंगा 50 सेशंस पर यूजर, तो उस हिसाब से मैं 50 डिवाइडेड बाई 64 कर दूंगा. दैट मेनी यूजर्स कैन यूज इट. अब की कहीं कहीं पे हो सकता है एक यूजर 100 सेशंस यूज कर रहा हो, 200 सेशंस यूज कर रहा हो. सो accordingly we have to divide that number of sessions by the public, the number of ports that we have. So we can say approx number of users. We can't say exact number of users. अभी मैं गूगल खोलूं, गूगल में कुछ सर्च करूं तो डीएनएस ट्रैफिक जाएंगे, फिर एचटीटीपी, फिर एसएसएल हैंडशेक होंगे, तो एक यूजर नंबर ऑफ सेशंस क्रिएट करते हैं. देखने में लगता है गूगल, लेकिन बैकएंड में बहुत चीज होते हैं. डीएनएस क्वेरीज आती है, डीएनएस रिप्लाई आती है, फिर HTTP TCP थ्री वे हैंडशेक होती है। HTTP कनेक्शन इनिशिएट होगा ना, तो TCP थ्री वे हैंडशेक से पहले फिर देखो, पहले थ्री वे हैंडशेक होगी, ठीक है। TCP थ्री वे हैंडशेक होने के बाद SSL होगा, फिर उसके बाद तो आई मीन मल्टीपल थिंग्स चलते हैं। ऐसा नहीं है कि सिर्फ जैसे हम लोग कोई भी प्रोटोकॉल यूज करते हैं, तो कोई भी वेबसाइट एक्सेस करते हैं, तो उसके पीछे बहुत सारी चीजें होती है, ठीक है। ऐसा नहीं है कि सिर्फ एक प्रोटोकॉल रन किया तो एक ही सेशन क्रिएट हुआ, ऐसा नहीं है। एक बार HTTPS करो तो DNS चला गया, फिर उसके बाद अ, अब मैंने HTTP रिक्वेस्ट किया तो वो TCP बेस्ड कनेक्शन है, तो TCP कनेक्शंस को चेक करेंगे। उसके बाद SSL रिक्वेस्ट जाएगा, उसके बाद HTTPS जाएगा, ठीक है। तो बहुत सारी चीजें हैं जो अ, बीच में बनती है, बहुत सारे सेशंस होते हैं। तो बेसिकली व्हाट आई मीन टू टेल इज, आई कांट से एग्जैक्ट नंबर ऑफ यूजर्स, it depends on the number of sessions created by users, that will decide how many users can access. But normally, if you ask me how many users approx, then divide, let's say if I see I have 64,000, right? I have 64,000 port numbers divided by 500 also if I do. It's like 128 sessions per user. So in this way, 128 users can 128 users can access it. Okay, so basically, I'm dividing. Let's say, for example, I'm getting this is a number of wait 64K divided by 500 users. I said so per user will have 128 sessions. So here I'm calculating about 500 users. Can 500 users be survived? Yes, it can be, but this would be very neck to neck. Okay, so what I would say, uh, let's say 64K, 64K port numbers divided by 300 users is equal to around 213 sessions per user. That is good enough. That is where we have a good buffer of port numbers also. So you can say one public IP, we can use it for 300, 400 users. That would be 30 minutes more. So this would be a good number. Okay. So one public IP, if I have 64K available port numbers, decent number of users that can access would be 200, 300 users. But it also depends on number type of traffic. अब सब आदमी वीडियो वीडियो ही देख रहा है तो कैसे सरवाइव करेंगे, वो डिपेंड करता है, ठीक है। सो डिपेंड्स। सो ओवरऑल one public IP can be used for multiple users, that is proven. एक पब्लिक आईपी मल्टीपल यूजर्स यूज कर सकते हैं, ये प्रूव्ड है, ठीक है। सो दिस वाज आवर ओवरऑल डिस्कशन। ओके, तो यहाँ पे एक सिनेरियो जो है मैं डिस्कस करता हूँ, जो डायनेमिक के लिए यूज करेंगे। जैसे मान लो ये फायरवॉल है। I'll give you a use case. After that, we'll end the class today. Practical, we'll do it tomorrow when the students will be present. Assume this is your firewall, and this is your LAN, this is your WAN, this is your firewall, and here we have PC. Here we have multiple PCs. So let's say here I have a multiple users. I have a multiple users over here. These all are in my LAN network, right? LAN network means what? Private IP. These all are having private IPs. And these private IPs, when they want to go outside, definitely they all have to get translated with public IP. So here I'll have a public IP. See, these all are the LAN network IPs. LAN network IPs. So these are the private IPs which needs to get translated while going outside, right? So now see here, private IPs and they need a internet access. They need internet access over here. This is our cloud, which needs an internet access. So LAN to WAN, whenever we are going, it's a private to public. So when it is private to public, whenever it is private to public, who is private, always you have to keep in mind. So here, my LAN network is basically private. My LAN network is always in this scenario. देखो अगर LAN में कोई होस्ट है, अगर उसको WAN की तरफ जाना है तो उसको ट्रांसलेट होना है ना. So these all are my private IPs. These all are my private IPs. LAN needs to go to WAN. So when LAN has to go to a WAN, it means LAN has to get translated to get internet access. So what is my LAN? It's my source, and this is my destination. So source needs to get translated in this scenario. That's why we call it as a source translation. Understood? We call it as a source translation because source has to get translated here because source is private. So this is where tomorrow we'll apply our translation. We'll see how source can be translated while going outside. So two translations we'll see tomorrow. Dynamic NAT and two translations we'll see tomorrow. And for destination, what we'll see, user will be coming from outside, either to reach LAN or to reach your DMZ. Right now, you guys are taking RDP access, right? In RDP, you are at outside and server is in my DMZ. So you are taking access from public to private, and your one thing you might have noticed, your public IP is always fixed. अगर तुम्हारा कोई पब्लिक आईपी अगर चेंज हो तो तुमको कभी एक्सेस ही नहीं मिलेगा. तो पब्लिक आईपी हमेशा चेंज होते रहता है. हाँ तो डायनेमिक स्टैटिक नैट यूज हो रहा है, नॉट डायनेमिक. स्टैटिक मींस आईपीज एंड पोर्ट आर फिक्स्ड. तो जहां पे भी कोई फिक्स वाली सिचुएशन आती है, आईपी हो या पोर्ट नंबर हो, जो भी फिक्स्ड है, दैट इज कॉल्ड स्टैटिक. दैट मीन्स यू केयर मीन्स तुमको याद रखना है कि यही आईपी है, यही पोर्ट नंबर है. दैट मीन्स यू केयर. व्हेन यू डोंट केयर, जैसे तुम घर से इंटरनेट एक्सेस करते हो, तुम कभी भी ये मालूम करते हो तुमने क्या आईपी क्या पोर्ट को ट्रांसलेट किया? कभी ध्यान रखते हो? नहीं करते. सो यू डोंट केयर. सो व्हेनेवर यू हैव अ केस यू डोंट केयर, दैट इज डायनेमिक. And whenever you have a case where you care, that is, there are different ways of remembering your translation. See, translation is not that tough. It's basically understanding. You have to understand things properly. So, static or dynamic, how do you understand? Wherever you see, you have to remember public IP, that's static. You don't have to remember, it's dynamic. I mean, these are the way of remembering the concept. सोर्स और डेस्टिनेशन में कैसे डिस्टिंग्विश करेंगे? सोर्स ट्रांसलेशन है या डेस्टिनेशन ट्रांसलेशन? यदि प्राइवेट आईपी इनिशिएटर है, यहाँ पे लैन से हम लोग इनिशिएट करेंगे, तो सो इनिशिएटर इज फ्रॉम लैन एंड लैन इज व्हाट? प्राइवेट. सो initiator means source and private IP means needs to get translated. Source translation. So these are some logics that we put to understand our translations.